This is day 22 of 50 days of tutelage. I'm going to be teaching algebraic expression. My class is going to be in three phases. Number one, I'm going to be covering basic algebraic expression. Oh, that sounds like B. And then number two, I'm going to be teaching binomial expansion, B, and I'm going to be teaching factorization as well. So everything is going to be moving from one phase to another. So let's start with basic algebraic expression. The first thing is, let's talk about algebraic expression in the first place. What are algebraic expressions? Basically, algebraic expressions are expressions that involve the use of numbers and letters. For instance, you can have like the number part and you have the letter part. So numbers, they just do what they do. They show magnitude of whatever it is. But letters, what do they usually represent in algebraic expressions? They can represent two things. They can represent unknowns and they can represent variables. They can represent variables. So what exactly is the difference between unknowns and variables? Actually, variables are a special type of unknowns. And how can you distinguish between them? So if you're a student of algebra or algebraic expression, you should be able to tell the difference between unknown and variables. So let me quickly explain that to you. So the first thing you notice is that these two are always existing in a given equation. So if you're given an equation, how do you know that the letters there represent unknowns or they represent variables? Now, it boils down to the fact that if you have, let's say, one unknown, that is, only one letter is being dealt with in that place. If it is one letter in that equation, then in that situation, it is an unknown. For instance, if you have 3x equals 6, in this case, x is going to be 2. It is an unknown in this place, then you have to solve for it. So, but in the moment you have just one equation, and you have two unknowns there, two letters there. For instance, now, let's say I made this one 3x equals 6 plus y. Made this one 3x equals 6 plus y. In this situation, these two guys, x and y, are no longer just unknowns. They have become variables. Reason is because they can take as many values as possible. They can take as many values as possible. For instance, one of the values that they can take here is that I can say x equals 0 and y equals -6. If you put that into this expression, it's actually going to be true. And I can also say that x equals 1, then y equals -3. If you put that into this expression, this is going to be true as well. So you can see that x and y, they can take as many values as possible. So therefore, they have become variables like that. But if it was only x in one equation, then you know you have. But if let's say you have 3x minus y equals 6, and then you have 4x plus 2y equals 7. Now, in this situation, you have two equations and you have two unknowns. In this situation, these guys are unknowns. They are not variables anymore. They are just unknown because you can have a specific value for them. Now, when I say specific value, sometimes the specific value can also be more than one. For instance, if this was 3x squared plus 5x minus 6 equals 0. Now, in this situation, you're going to have more than one value for x. It is still an unknown as long as it remains a single equation with one unknown. So it remains an unknown. In this case, you have two equations, two unknowns, then they remain unknown in this place. So it's before you can have it to be a variable, it has to be that the number of unknown passes the number of equations that you are given. Then you begin to have what we call variable at that point. You begin to have variable because now you are going to have several values of the letters that are given in the expression. So algebraic expressions are basically the convolution of numbers and letters together. And letters, like I said, they represent unknowns, and then they can also represent variables as well. But that's not the major thing here. So how do we actually simplify basic algebraic expressions? Basic algebraic expressions, like I said, they involve letters and all of that. So one thing you need to know is that you need to do something we call collecting of like terms. Collecting of like terms, such that if I give you several expressions, let's say I give you something of this nature, say 3x squared minus 4xy plus 6x minus 13xy plus 2x squared minus 5 plus, let's see, just plus x. Now, this is an algebraic expression. And as you can see here, it has a lot of letters being used, unknown variables. Of course, in this case, there will be variables and all of those things. Now, how do we now simplify this basic algebraic expression? This is just simple high school math. You can just collect like terms. What does it mean to collect like terms? It means you are grouping things together based on what they look like. Now, look at the first term here. We have 3x squared. So this x squared will determine what like terms we're looking for, not exactly the numbers. So if you like 3x squared here, so you look through everything that you have here, you realize that when we get to this place, we have another x squared term. So you can group them together. So grouping them together, you have 3x squared plus 2x squared. What you notice here is that, I know from common knowledge, whenever you have to move something, it most likely always involve a change of sign. But in this case, I did not change the sign. Why am I not changing the sign? It's because change of sign involves, there has to be an equation. And I'm going to explain that very soon. So in this place now, you are grouping this. There's no equation inside, equal to sign inside. So therefore, just group them together and carry them with their corresponding signs. Now you have the next term is negative 4xy. So look through, do you have a term that involves xy? Yes, this is the term. So you bring them together, negative 13xy. Then you have plus 6x. Do you have a term with x? You have 6x plus x. And then we are done with this, we're done with this, we're done with this. So the only thing that is left is negative 5, which does not have anything that matches with it. So here you simplify and you do the expression. 3x squared plus 2x squared, that will be 5x squared. Negative 4xy, negative 13xy. So what you're going to have is negative 17xy. And you have plus 6x plus x, that will be plus 7x. And you have negative 5 follows. So you have been able to simplify this algebraic expression. But what if you have something of this nature? Let's say you have 3x squared plus 5y minus 6x squared equals 3y plus 6 xy minus 4y squared minus 4y squared. So let me put a kind of 10y squared here. So in this situation, the one thing I want you to notice first is that we can also collect like terms here, group things that are the same together. So let's start with this 10y squared. Now, but when equations are involved, one of the things I always advise is that you should first of all do them side by side. There is the left hand side of the equation and there is the right hand side of the equation as well. So one thing I want to always advise is that deal with the left hand side, deal with the right hand side separately before you start crossing over. Before you cross over, so we have 10y squared here. So look at this place. Do we have anything that has y squared as well? I do not think so. So therefore, let 10y squared remain. You have 3x squared here and you have negative 6x squared here. These two can actually be grouped together. 3x squared minus 6x squared. If you notice, I'm not changing sign. That is because both of them are on the left hand side and I'm not doing any form of crossing over yet. So I'm going to leave it like that. Then you have plus 5y. So we are done with the left hand side grouping. Then on the right hand side, they really don't have things in common. So you have 3y. So by the way, you cannot combine 3y and 4y squared. You cannot combine it because they might be the same letters, but they have different powers. So 3y plus 6xy minus 4y squared. Now that we're done with this, you can simply simplify this. This will be 10y squared. So 3x squared minus 6x squared, that's going to be negative 3x squared plus 5y equals 3y plus 6xy minus 4y squared. So now that you're done with the grouping of the left hand side and right hand side, so you can now begin to do some crossing over. When you're doing crossing over, know that there will be a change of sign. Whatever the sign is, if it was a positive sign before, it will become negative. It was a negative sign before, it will become positive. And that is what happens when you're crossing from one side of the equation to the other. So you can decide to group all the y's in this place. For instance, you have 10y squared here. If you look through, you have another y squared in this place, but it is negative 4y squared. So when it comes to this place, so you have 10y squared, it's going to become positive 4y squared. And you have negative 3x squared. Do you have any other x squared again? No, I don't think so. Then you have in this place you have plus 5y. Then you can bring in the 3y. 3y is positive here, so it becomes negative 3y. You can decide to leave the 6xy on the other side. Like it's your choice. It depends on what you're doing. You can decide to take everything to the left hand side. You can decide to leave them. It's just based on what you want. Just follow the rule. When you're crossing over from one side of the equation to the other, you always have to do a change of sign. But when you're not crossing over, even if there's the equal to sign, you still maintain the same sign as long as you're not crossing over. So if you simplify this, you have 14y squared minus 3x squared plus 5y minus 3y, that's going to be 2y, and this is going to be equal to 6xy. And that has simplified the algebraic expression. So that's basic simplification of algebraic expression. Now let's go to binomial expansion. Now, so what is binomial expansion? Binomial expansion is simply the way we actually expand binomial. Maybe you're adding two things, let's say x plus y, or you're doing some a minus b. Now, if you begin to raise this thing to powers of n, like from n going from 2, 3, 4, and it goes on and on like that. So if you're doing somewhat like an expansion like this, what you need to do is that there's a system to follow. Of course, there is the normal term that if you have x plus y squared, what does it really mean? It means x plus y multiplied by x plus y. And so what do? You use the FOIL method, which is actually basically you picking each thing in this first case, which is x. You use it to multiply everything in here. So you have extract this x outside and then bring this x plus y close to it. Extract this positive y as well and bring this x plus y close to it. So that's basically how you expand. You begin to extract everything on the left hand side one after the other. Then you couple it with x plus y, the other thing in the parentheses. You couple it with it all the time. So in this situation, you're going to have x multiplied by x, that's going to be x squared. X multiplied by positive y, that's going to be plus xy. So signs are very, very important as well. And some of your basic sign thing that you need to understand is a positive sign times negative sign is going to be negative sign. Negative sign times positive sign is going to be a negative sign. Positive times positive is going to be positive sign. Negative times negative is going to be a positive sign. And then it works for division as well. So let's proceed. So in this case, you have positive y times x, that's going to be plus yx. And then y times y, that is going to be plus y squared. So in this case, you have x squared. xy and yx, they are the same thing. So you can just make them 2xy. Then this will be plus y squared. So, but what if this is now beyond 2? What if this is 3? That implies that you have to do this thing 3 times. After you're done with this group of 2, then you multiply with another x plus y again. Now imagine it is now 10. How do you go about that? So this is what we do. We use what we call the binomial theorem. And the binomial theorem simply tells us that if you have x plus y raised to power n, then the expansion is going to be x raised to power n plus n combination 1. Then you have x raised to power n minus 1 multiplied by y. Then you have plus n combination 2. Then you have x raised to power n minus 2. Then you have y squared. This goes on and on until you get to y raised to power n. Now, so how do we now do this? Don't worry about all this gimmick, all this combination and everything. I'm going to show you a very better way to go about it now. And we're going to do one example. So it's using the binomial expansion. So the binomial expansion, use the Pascal's triangle. What is the purpose of Pascal's triangle? So there are 3 things in all this expansion. The first thing is that we always have the coefficient part, which is this. The second thing is the term with x, and the next thing is the term with y. So by the way, in your own case, it may not be x and y. It might be a and b. It might be anything. So what I mean by x term is the first term. What I mean by y term is the second term. So how do we use the binomial expansion in this place? The Pascal's triangle takes care of the coefficient part. And so let me quickly show you how to build the the Pascal's triangle. So just start with a 1 and 1. Know that it's always going to start with 1 and end with 1. So starting with 1, then you look at the previous thing that you have done. So always start with 1 and 1. That's standard. So then add the 2 of them together. 1 plus 1 is 2. So go to the middle and trace it down. So I'm going to put the 2 down here. Then If you look at the next, so you added 1 plus 1. When you are done, the last number is going to be your new beginning. Now, 1 plus, there's nothing else again. That means that you are done. You just finish it with 1. Don't worry, it will make sense now. So what do? You start with 1 to go to the next line. So the first number here is 1. You add it to 2. 1 plus 2 is 3. So go to the middle and trace it down. So you have a 3 down here. What was the last number that you added? That was 1 plus 2. So 2 is the last number. Can you still add something else? 2 plus 1 is 3. Go to the middle and bring it down. So now we are done with 2 plus 1. 1 is the last number. Do you have another one? No. So that's the ending of that. So you start with 1 again. 1 plus 3 is 4. Go to the middle, bring it down. 3 plus 3 is 6. Bring it down. 3 plus 1 is 4. Bring it down. Then 1 is the last digit. Can you go again? No. Let me do one more. 1. 1 plus 4 is 5. So go to the middle, bring it down. So you have a 5. 4 plus 6 is 10. Go to the middle, bring it down. That's a 10. 6 plus 4 is 10. Go to the middle, bring it down, 10. 4 plus 1 is 5. Bring it down, 5. And then do you have anything again? That's all. So now this is your Pascal's triangle. Of course, you can put the apex here if you like. Now, what is the purpose of this thing? Like I said, they take care of the coefficient part of your binomial expansion. And you see, this other one is very, very easy. So let's quickly build something now. So if you have, let's say, x plus y raised to power 4. So what will this expansion be? Like I said, 3 things are going to be taken into consideration. Number 1 is the coefficient. Number 2 is the term of x. And number 3 is the term of y. Now, one thing you notice about the term of y is that the first case, the term of x will take the highest power. So the term of x will take the highest power. So in that case, you have x raised to the power of 4. So now let's move to the second phase now. This is where the work starts. So you must deal with coefficient first. So if you look at this Pascal's triangle, look at this level here. This is what represents the power 4. Now, we are done with the first term. The second term, what will be the coefficient? The coefficient is 4. So you start with that 4. Then the next thing that comes is the x term. So x. What you notice is that the power of x begins to reduce by 1. So x was raised to power 4 before. In this case, it's going to be raised to power what? Raised to power 3. So it's going to be falling by 1. But y now will begin to take the power. So y was raised to power 0 here initially. That's why you don't have it there, because y raised to power 0 is 1. So y will take the power of 1 in this situation. Then you go further. What's the next coefficient going to be? The next coefficient is going to be 6. So you have 6x. Now, let me write that 6 properly. You have 6x. Now, x was to the power of 3 in the previous case. So it will fall also by 1 again. From 3, it becomes 2. Then y add a power of 1. It rises up to become y raised to the power of 2. Plus, what's the next coefficient? The next coefficient is 4. So you have 4. Then you have x. X is now going to be to the power of 1 because it was 2 initially. Then you have y. Y will go up and y will become y to the power of 3. And then you go to the last stage. The last stage is going to be y will now take the highest power, which will be y raised to the power of 4. So with this, you have been able to do the expansion of x plus y raised to the power 4. So what if it was a negative thing? So what if it was x minus y all raised to power 5? What if it was x minus y all raised to power 5? So how do you do that? So you don't need to worry yourself at all. Just know that if the first term here is the positive term, so always try to make the first term here the positive term. It is easier that way. You can do it anyway, but like it is easier to make the first term positive term. If the first term is always the positive one, so what you need to do is, so I think I'm gonna put it right up here so that you can follow what I'm doing. Yeah, I'm just gonna put it right here. So now, since it is positive, so this is what we're gonna be doing. We have 5 is the first coefficient that is after the first term. So x is gonna be x raised to power 5. So follow the rule. I said the first guy is going to take the highest power. Now, so is what's going to happen. Since the first term is positive, then the second term is going to be negative. The power is going to be, the sign is going to be oscillating between plus and minus. So this is what I'm talking about. We have used positive for the first term. So the second term is going to be a negative sign like that. And what will be the coefficient? Negative 5. So x is going to take a power of, if you can answer that. So from 5, it falls down to what? 4, and y will surface. Now, we are done with negative sign. We're going to use a positive sign next. What is the coefficient? 10x. X will now become to the power of 3, and then we have y will be to the power of 2. Then we're done with positive sign, negative sign again. What's the new coefficient? Also 10. 10x to the power of 2, then y will be to the third power. Then from negative sign, we'll move to positive sign. So that will be 5. X will be to the power of 1, and y will be to the power of 4. And finally, you have another negative sign. So you have negative y raised to power 5. So you can see the way it's changing. The sign is changing from positive, negative, positive, negative, positive. However, if it was negative y plus x, or let's say you have negative x plus y raised to power 5. So this one now is you have to be considering the power. If the power is an even power or an odd power. So it actually like stresses you out. You don't have to worry about it if it was not so. So that's exactly what binomial expansion is all about. So I believe with this, you should be able to do any form of binomial expansion. So your classwork, you should do this. If I give you 2x minus 3y raised to power 3, you should be able to expand this. It's very easy. Just assume that this is your first term and assume that this is your second term. And when you are done with that, I would like you to comment whether you got it right or not. So that's the second phase of this part of this class. The next thing I want to teach you is factorization. So how do we factorize? Factorization is simply all about symmetry. So you need to watch the symmetry of a given question before you can factorize properly. So I'm going to give you some very little hint about how you factorize. I'm going to start with some things we call difference of powers. Difference of powers. So I'm going to start with difference of squares. So if you have, let's say, something like x squared minus y squared, we call this thing difference of two squares. And to factorize this, just know that x minus y is always going to be a factor. So you have x minus y multiplied by x plus y. This is difference of two squared. You need to familiarize yourself with this. But I'm going to teach you a pattern. Let's say we want to do difference of 2 cubes now. Now, at the same time, x minus y is also going to be a factor here. So x minus y is going to be a factor. So how do we know what is going to be left here? I want to show you this thing. You remember the binomial expansion I just taught now. So forget about the coefficient. And since x minus y is already done, so if x minus y is already done, it would have reduced this thing by power of 1. So therefore, you have power of 2 in place. So the first thing that shows here is x raised to power 2. Now, purely, everything is going to be addition. Everything is going to be addition. So x raised to power 2 plus, now, x will begin to fall in that power now. So from power 2, it goes to power 1, and y will surface. So you have y raised to power 1 plus. Now, when x gets to the last stage, x will become to the power of 0, and y will take the power of 2. This is the factorization. So let's do this one together. X raised to power 4 minus y raised to power 4. So what is still going to be the factor? X minus y is going to be a factor. So bring x minus y out. Then you have what? You have x. So it has reduced by power of 1. So that will be x to the third power. Then plus x will now be to the second power. And then y will be to the first power. Then plus x will be to the first power, then y will be to the second power, and finally you have y to the third power. So this is how you do factorization of difference of any power, difference of power, and that is that. Now we can also do a sum of power, like let's say x plus y and raised to power something. The only difference is that this power must be odd before you can factorize them. If it is, let's say, x squared plus y squared, you will not be able to factorize this guy. But if it is x raised to power 3 plus y raised to power 3, then you can factorize this. It's similar to the way we factorized this here in this place. The only difference is that the power will be oscillating here. So you have x plus y will be a factor. X plus y will be a factor. So in this parenthesis now, you have what? X to the power of 2. But this time around, it will not be plus xy. It will be minus xy and plus y squared. So you cannot do x raised to power 4 plus y raised to power 4, but you can do x raised to power 5 plus y raised to power 5. So what's going to be a factor? X plus y is going to be a factor. And you're going to have what? X raised to power 4. Now minus x raised to power 3y plus x raised to power 2y squared minus xy raised to power 3, then you have what? Plus y raised to power 4. So this is how it goes on and on. So that's the first step of factorization. The next thing I want you to know is that sometimes we have to group. We have to actually like always group things into twos. And oftentimes when we have to group things into twos, we need to also make them like, if let's say we're given three terms now, you need to also make them something like you need to group them into four terms. So let me show you what I'm talking about. I think saying it is not as good as showing you what I really mean by this. So what I'm saying is that, let's say for instance you have 6x squared plus 11x plus 3. I'm still going to explain this thing under quadratic equation. So, but for the sake of this class, I'm just going to explain a little bit. Now, I want to factorize this thing. There are three terms here. The way I can factorize this thing is that I can say that x is common here and I factorize x. But what about this 3 that is left here? So one thing you can actually do is that you can try to see a way you can split this 11x. So it seems like the transitioning stage whereby you have a power of 2 here, and then this one you have no power at all, and this one has a power of 1. So 2 is between 1 is between 2 and 0. So 11x seems like a very good place to transition. It seems like a very good place to what? To transition. So what you need to do is that you need to look for a way to actually separate this thing. Now, I will still teach it under quadratic equation, so I'm not going to be putting much detail in this. I think quadratic equation should be one of our next class. You have the timetable already for the topics we are doing every day. Anyways, you can always check the playlist, you see there. So this is going to be 6x squared plus 9x plus 2x plus 3. So what have I done here? I've been able to break down 11x as 9x plus 2x. Now, why is it not 5x plus 6x? Why is it not, 1x plus 10x? That I'm going to explain in quadratic equation. So now you can see that here now I can say something is common here. That is 3 is common and x is common. So if I factorize 3x in this place, I'm going to be left with 3 out of 6. That will be 2 left. Then x is gone. You have x left plus 3x is gone. So you have only 3 left. So you have 2x plus 3. Plus, in this place, there seems to be nothing. So the only thing I can factorize is 1. So that will be 1, 2x plus 3. And so you have what? Now, 2x plus 3, 2x plus 3 now. So you can just bring out one of them since it is common to both sides. So you have 2x plus 3, then you have what? You have 3x plus 1. And this is a factorization of this expression. Like I said, I'm going to explain this better in when we're doing with quadratic equation. And so there are so many other things that you can do under factorization, but for the purpose of this class, I would have to end it at this point now. So like I always say, if you have not subscribed to the channel yet, you should do that and like and engage the video as well. It helps a lot. I guess I'll see you in the next one.